Welcome to lesson 66. We're going to solve quadratics that are in the form ax minus c equals 0 using square roots. So pretty much they look like binomials on one side of the expression equal to 0. Here's our CFS. We're going to use algebra basically to solve for 0. And make sure you keep all your work on the page to demonstrate you know how to solve this type of equation with a square root. And we're going to provide two solutions when calculating the positive integer for square roots. All right, let's look at our first example. X squared minus 4 equals 60. So I'm going to solve this the way I normally would, by first adding 4 to both sides so that I only have x on one expression. So x squared is equal to 64. And now the only thing for me to do is the inverse of x squared, which is to apply the square root symbol. And I do this to both expressions. So x is equal to, and the square root of 64 is 8 and negative 8. So I'm going to have both answers there for x. You can also express this as x is equal to plus or minus 8. Let's try the second example. 4x squared minus 100 is equal to 0. Add 100 to both expressions. 4x squared is equal to 100. Divide by the coefficient 4. X squared is equal to 25, so now I can use my square root symbol. X is equal to plus or minus 5. All right, hit pause and jot this down into your notes. Okay, it's your turn to try a few guided practice problems. Try the first one on your own. Hit pause and try it out. Okay, and we'll do the reveal in 3, 2, 1. X is equal to plus or minus 9. So this one was pretty simple. All you had to do was transfer over the 81 and then find the square root of 81, which is 9. All right, let's try the second one. The second one is going to be a little bit trickier. Hit pause and try to solve it. Alright, let's try to reveal on the second one. This again was challenging, but not impossible because we've done this type of math before. In this case, x is equal to plus or minus 4 square root 2. So it's the same level of mathematics. We still know the first few steps pretty well. We're going to divide by 2, and this is where it may have looked a little tricky because we've gotten used to seeing perfect squares for x squared is equal to some perfect square. But now we know this will not always be the case, but we do know how to solve these problems. So we're going to find the square root of 32. Just find the factors of 32 and see if any are perfect squares. In this case, we know of one. 16 times 2 make 32, and 16 is a perfect square. So that's how you would get your 4 square root 2. Okay, and just a reminder, like in any other math problem, you can just substitute your values to check your work and just check your math for a second time. So I put in the math there for x is equal to plus or minus 9. I'll show you what it looks like for the second example with 4 square root 2. We're going to substitute for x. And given this is a square, I'm going to expand this. So that just means 4 square root 2 times itself. Okay, now I'm going to do a little bit of just simplifying. So just watch how I'm just rewriting this. I'm putting the 4's next to each other because it's easy. And the square root 2's next to each other. So I want you to notice something with the patterns. clearly we know 4 times 4 is just going to be 16. And square root 2 times the square root of 2 is going to give us 2. And here we have it. 2 times 32 minus 64 equals 0. And 2 times 32 is 64. 64 minus 64 is equal to 0. So this will be true if they were both positive, or even if they were both negative numbers. We would still end up with the same answer at the end. Okay, so that's it for today's lesson. I want you to just keep in mind again that we're just using algebra. Please make sure you're keeping all your notes captured on the page to solve for x. We are finding the square root of x for these quadratics. And remember that some of the expressions, square roots, will not be perfect squares, but we do know how to use radicals to simplify them. All right, that's it for today's lesson. I'll see you in the next one. Be well.